Desiccants versus air dryers. In injection molding, both desiccants and air dryers are used to remove moisture from plastic resins before molding, but they differ in their approach and suitability. Desiccant dryers use a desiccant material to adsorb moisture, while hot air dryers use heated air. Desiccant dryers are generally preferred for hygroscopic resins, those that readily absorb moisture, while hot air dryers are more suitable for non-hygroscopic resins. Desiccant dryers. Mechanism. Desiccant dryers use a closed-loop system where heated, dry air is circulated through a desiccant bed. The desiccant absorbs moisture from the resin and then is regenerated to remove the captured water. Advantages. Superior drying. Desiccant dryers excel at removing moisture to very low dew points, which is crucial for high-quality parts. Consistency. They provide consistent drying conditions and can be used for a wide range of resins. Disadvantages. Cost. Desiccant dryers can be more expensive to purchase and operate than hot air dryers. Energy consumption. They can consume more energy than hot air dryers, especially when drying at higher temperatures. Air dryers, including hot air and compressed air. Mechanism. Hot air dryers heat ambient air and pass it through a hopper filled with resin, which removes surface moisture. Compressed air dryers use compressed air, which generally has a lower moisture content, to dry the resin. Advantages. Lower cost. Hot air dryers are generally less expensive than desiccant dryers. Simplicity. They are relatively simple to operate and maintain. Disadvantages. Limited effectiveness. They are not as effective at removing moisture to low dew points as desiccant dryers. Suitability. They are best suited for non-hygroscopic resins and may not be ideal for materials that readily absorb moisture. Choosing the right dryer. The best type of dryer depends on the specific resin being used and the desired level of dryness. For hygroscopic resins, desiccant dryers are often the preferred choice, while hot air dryers may be suitable for non-hygroscopic resins or for drying at higher temperatures. Compressed air dryers can be a good option for smaller molding applications. Hygroscopic resins are materials that readily absorb moisture from the air or liquid water. They have a strong affinity for moisture, and this absorption can affect their properties and performance, especially during processing like injection molding. Examples of hygroscopic resins. Nylon. PA nylon is one of the most well-known examples and can absorb up to 9.5% of its weight in water. ABS, acrylonitrile butadiene styrene, is another common engineering plastic that absorbs moisture. Polycarbonate. PC polycarbonate is a clear, strong plastic that is also hygroscopic. PET, polyethylene terephthalate, often used for water bottles, can be significantly affected by moisture if not properly dried before processing. PBT, polybutylene terephthalate, is another engineering polymer that is hygroscopic. Acrylic. PMMA acrylic is a transparent plastic that can also absorb moisture. Polyurethane. Polyurethane, used in various applications, is also hygroscopic. Other hygroscopic resins, many other engineering polymers and some composite materials are hygroscopic. Why moisture matters. Processing issues. Too much moisture in a hygroscopic resin can cause problems during processing, such as injection molding, leading to defects like silver lines, bubbles, and weakened strength. Property degradation. Moisture can degrade the properties of the resin, affecting its durability, impact resistance, and overall performance. Storage and handling. Hygroscopic resins need to be stored in a way that minimizes moisture absorption, often in sealed containers or dry storage environments. Drying hygroscopic resins. Importance. Drying hygroscopic resins before processing is crucial to prevent moisture-related problems. Methods. Various drying methods are used, including using desiccant dryers, hot air ovens, and even specialized vacuum systems. Post-drying handling. After drying, it's important to process the resin quickly to avoid reabsorption of moisture from the atmosphere. Non-hygroscopic resins are generally hydrophobic and don't readily absorb moisture. Common examples include polyethylene, PE, polypropylene, PP, polystyrene, PS, and PVC. These resins typically exhibit a lower affinity for water compared to hygroscopic resins like nylon. Definition: non-hygroscopic resins are those that don't readily absorb moisture from the environment, unlike hygroscopic resins which have a strong affinity for water. Moisture absorption: non-hygroscopic resins can still have moisture on their surface, but they don't absorb it internally into the pellet structure. Examples: some of the most commonly used non-hygroscopic resins in manufacturing are polyethylene, PE, used in various applications, including packaging and bottles. Polypropylene, PP, used in packaging, containers, and other applications. Polystyrene, PS, used in packaging, disposable items, and insulation. PVC, polyvinyl chloride, used in pipes, flooring, and various other products. Drying: while non-hygroscopic resins don't absorb moisture internally, they can still have surface moisture that needs to be removed before processing. This can be done using methods like hot air drying. Moisture effects: moisture in resins, whether hygroscopic or non-hygroscopic, can lead to various issues, including cosmetic defects, such as splay, silver streaking, and internal bubbles. Reduced physical properties, including loss of strength and impact resistance. Processing problems, like poor flow or incomplete fusion.